Hopefully you can see some major similarities between this problem and the last one. Again, you're given f prime, and you're asked for intervals over which f is decreasing, and this time we're looking for local extrema, so both max and min. And then some justification as well. And so let's just think about what we're looking for here. F decreasing would be f prime less than 0. Extrema would be f prime going from negative to positive for a min. We'll draw it there so we can see the negative to positive behavior. And f prime plus to minus for a max. Positive slope to negative slope. So these are the things we're looking for, but we can't use a calculator this time. So we have to revert to some of the things we've learned in pre-calculus and algebra 2. I know that my f prime has several zeros. I can see that I have a 0 from this first factor at 0, the second factor at 2, the third factor negative 4. I can also see that I'm going to bounce, cross, because this is an odd power, and bounce again because of the even power. But if we forget about that, I will show an alternative approach. But definitely we need to plot our zeros. Negative 4, 0, and 2. Now let's see what kind of polynomial this is. This is 2, 1 is 3, 4, 5, so this is y equals negative ax to the 5th power. Because I counted 2, 1, 2, added them all up, that gives me 5. And I have a negative leading coefficient. So that means my function will go from low or from high to low because of the odd behavior and the negative leading coefficient. And I know that I bounce at 4, bounce at 0, cross at 2. So we'll show all that behavior. Coming from above, I bounce some more, and I cross, and that gives the right end behavior. So now if we're looking for decreasing f prime less than 0, then this is from 2 to infinity. So that would be from 2 to infinity. And if I'm looking for relative extrema or local extrema, the only time that I cross is x equals 2. So we would say at x equals 2, we have a derivative going from positive to negative, that's a max. I can't just draw this picture and let that be my justification, but that's helpful for me. Max because f prime changes from positive to negative. Well, we also had critical points, some more vocabulary. Critical points at x equals negative 4 and 0, but these are neither max nor min. Justification because f prime of x doesn't change signs. So that would be the reason. Now, we've got all those reasons. We don't have to redo that. But what if we forget some of this kind of bounce behavior? Maybe I forget what negative x to the 5th looks like. All I know is my zeros. I think we can all correctly come up with those. 0 at negative 4, 0 at 2, 0 at 0. So now what I'm going to do is I'm just going to test. I'm going to test a value like 1. So I'm going to put it in for every x. I put a 1 in here, I put a 1 in here, and I put a 1 in here. Well, 1 plus 4 is 5, and 5 squared is 25. That's positive. 1 minus 2 is negative, and 1 squared is 1 times negative 2 is negative. Now, when I multiply a negative times a negative times a positive, I get a positive. So that means this area is positive. Now, if I remembered the bounce behavior, I'm all done, because I can just say, oh, positive, and I cross. This must be negative. And all the other times I bounce, so I'm going to be plus and plus again. All the blue is positive, and the one green is negative. But if I forget my bounce cross behavior, I can just test more values. I know 1 was positive. That's the only one I know. So that means I have to test a number greater than 2. So let's test 3. Now every one of these is going to get a 3 in here. 3, 3, and 3. Well, 3 plus 4 is 7. 7 squared is positive. 3 minus 2 is positive. 3 squared is positive, but multiply it by a negative and we get a negative. So a negative times 2 positives makes this negative, just like we thought. Now let's test some other values. Test something between 0 and negative 4. Let's test negative 2. Oh. Let's test negative 2. Negative 2, negative 2, negative 2. Well, we've still got a positive here. This is negative, and this is also negative. Negative times a negative times a positive is a positive. So that stays positive, and let's test one more. Something less than negative 4, like negative 6. Negative 6 minus 2 is negative 8. That's negative. Negative 6 plus 4 is negative 2, but I square it and I get a positive. And this is still negative. So I've got a negative times a positive is still positive. So no matter how I do it, it all results in the same thing. Coming up, bouncing, bouncing, crossing through. Graphically, of course, is faster if you can get good at that. And now all of these justifications are the same, whether you have just a sign, test, positive, 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 minus, or your actual graph.